In this video, I present you InverseCoder. InverseCoder is still a research project and I don't see any weights or code at the moment, but I'm very hopeful that very soon they are going to release it, and I'm more than sure that it is going to be very interesting testing and benchmarking when it comes out. The thing with this project is that it deals with a very unique limitation of existing frameworks, especially when it comes to coding LLMs. Code generation, which aims to generate code that satisfied the user's intent from input, output, or natural language, has been a significant challenge in computer science from decades and decades. Recently, all of these open source and closed source LLMs like GPT 3.5, 4, 4.0 have enabled the generation of general purpose code like Python, JavaScript based on natural language, making them broadly applicable in the fields of programming assistance, computer vision, science, and other sort of intelligence. To develop high performance open source models, researchers have leveraged these closed source LLMs to generate datasets of instruction and code, then distilled these datasets into smaller open source code LLMs via instruction tuning. For example, Code Alpaca was fine tuned on 20,000 instruction code pairs generated based on GPT 3.5 with self instruct. Also, they used a method that creates a diverse set of instruction data from GPT 3 for code generation, and there are a lot of other details around it. This particular research, Inverse Coder, explores how to improve an instruction tuned code LLM by curing itself rather than curing a closed source LLM. And they have made two key observations, and it is also evident from this architectural overview from their paper. So the first observation is that while generating multiple code implementations from the same instruction can often lead to incorrect programs, generating multiple instructions from the same code often results in a diverse set of correct instructions. Secondly, for a fine-tuned code LLM, there is mismatch in translation ability. Translating codes into instruction is more straightforward than translating instructions into code. That is why, given a fine tuning corpus for code generation, it is possible to use the fine tuned LLM to generate additional high quality instructions from the same data, obtaining additional fine tuning data with an increased diversity of instruction. And that is where this project Inverse Instruct helps, which is a simple yet effective instruction tuning approach based on self generating multiple instructions from code snippet. Inverse Instruct, as you can see in this picture, starts with an instruction code corpus and a code LLM fine tuned on it. First, they clean and extract code snippet from the corpus, then let the code LLM translate these code snippets into new instructions. Then they use code LLM to evaluate and filter consistent instruction code pairs from the newly generated data. Finally, the filtered dataset is combined with the original instruction dataset, and then the base model is fine-tuned on combined dataset. Using Inverse Instruct, they have developed InverseCoder, which is a series of fine-tuned code LLMs that achieve state-of-the-art results. But I don't see any code at the moment, so I can't really confirm that. So it is simple yet effective instruction tuning approach exploiting the mismatch of code generation and instruction generation. So hopefully soon they are going to release the weight and code, and then I will install it locally and then we will play around it. But all in all, this whole idea and notion of enhancing the capabilities of open source code LLMs by leveraging self-generated data for instruction tuning rather than relying solely on data from powerful closed source LLMs like GPT-4o is quite good. I really like this one because I think effectiveness of this methodology is really going to be a game changer if what they are saying is true, and we can only tell it after checking it out. There are two limitations which I will describe towards the end. First, the performance of their approach is contingent upon the base model capacity to accurately summarize code. And also, the generation of synthetic data relies on access to high quality code snippet dataset. And both of these requirements are not trivial. So hopefully we will see something quite good soon, and then I will keep you posted. So that's it, guys. Let me know what do you think about this inverse coder. If you like the content, please consider subscribing to the channel, and I'm also going to put the link to this paper in video's description. Thanks for watching.